We studied a little bit about alkanes, what they are, how we separate them from crude oil, and today I wanted to look at how the size of the alkane affects the properties. So let's remind ourselves about solids, liquids, and gases first of all. So here is a diagram of a generic solid. Now this could be anything. All of the particles in a solid are held together, they're in contact, and they're held together so that they don't move. We know this is about a solid. In an alkane, the particles are actually molecules. They are carbon and hydrogen are two different elements, and they're chemically bonded together, so they are molecules of a compound. So we have our molecules held in place so that they can't move and they're in contact. So what does the holding, I hear you cry, the thing that's holding them together is called intermolecular force. Inter means between, molecular means molecules, so intermolecular means between the molecules. So there is a force between the molecules, an intermolecular force holding them in position. So when we turn our molecules of our hydrocarbon or our alkane into a liquid, we know that they start to move around. They're still in contact, but they are able to move around. So we end up with a disordered structure with particles in motion. And this is because the intermolecular force isn't strong enough to hold the particles in position above a certain temperature. When we get to that temperature, when we have that amount of energy, the intermolecular forces are too weak to keep the molecules in position, so they start moving around. And if we raise the temperature even more, there's even more energy there, and the intermolecular forces are not strong enough to even keep the particles together anymore, and we end up with them spreading out and it becoming a gas. So when we heat things up, we provide the molecules with energy to overcome this intermolecular force. Let's have a look at how this applies to methane, CH4 at the top, and hexane, C6H14 at the bottom. Now, they are both alkanes, and you can see that the size of the molecule is very, very different. Okay, you can see that we have a solid hexane. It's in an ordered structure down beneath, and the methane, it's kind of difficult to show, but it's supposed to be a liquid. If we were to heat these up, and I say heat these up to minus 162 degrees C. So if we were to heat them up from a colder temperature than that, we would find that actually methane turns from a liquid into a gas at minus 162 degrees C. Whereas hexane, we wouldn't see any difference at minus 162 degrees C. We'd actually have to heat that up to minus 96 degrees C in order to get hexane to even melt. So the intermolecular forces in methane are completely overcome at minus 162 degrees C, whereas in hexane, they are still holding the molecules in place until minus 96 degrees C. And in fact, we have to heat hexane up to about 68 degrees C before it evaporates, before it becomes a gas. So I've just tried to show that here with some bars. You can see if we start from the left-hand side, methane is a liquid up until minus 162 and then turns into a gas for all temperatures above that, whereas the hexane turns from a solid to a liquid to a gas, with its boiling point being 68 degrees C and its melting point being minus 96 degrees C. So what does this tell us? This tells us that the strength of the intermolecular force is different. Now, intermolecular forces are weaker than bonds. So all intermolecular forces are pretty weak. However, the ones in methane compared to the ones in hexane are even weaker. So methane has the weakest intermolecular forces out of our two that we've got here. And that's actually a pattern. The longer the hydrocarbon chain, you will find that the higher the boiling point is. So alkenes are molecules. The more carbon atoms in the alkane molecule, the higher the boiling point. And that's because the intermolecular forces in the longer chains are stronger. Now that's not the only property that we could look at. Viscosity is a word that we need to know. Viscosity means how sticky something is. Marmite is viscous, water is not. So the stickiness, or how quickly it flows, is really the definition. But you can think of it as stickiness. You should be able to work out where this is going, because if we have forces holding the molecules together and those forces are stronger, then that means that we are going to have more stickiness the more force we have. And so we see the same pattern for viscosity as we did with boiling point. The more carbon atoms in the alkane molecule, the higher the viscosity, because we have stronger intermolecular forces in the longer chains. The next property is volatility. Volatility is how easily something evaporates. So if I have something which is volatile, it will evaporate very, very, very quickly. And if I have something which is not volatile, then it will not evaporate amazingly quickly. Notice I've said evaporate there rather than boil. Water does evaporate below 100 degrees. Okay, we know this because puddles dry up. But if I was to take a puddle of hexane and I was to take a puddle of water, you'd find that the hexane would evaporate faster. And so hexane is more volatile than water, if you see what I mean. Okay, even though neither of them would be boiling at that point. So volatility is how easily a liquid evaporates. And again, this is related to the number of carbon atoms in the alkane molecule. You might have suspected this already. If we have more carbon atoms, because that raises the boiling point, we're going to lower the volatility. So the higher the boiling point, the lower the volatility is going to be as well. And again, that's because we have stronger intermolecular forces. The last property is flammability, and there's a lot of things which affect flammability. Flammability is how easily something catches fire. Now, because of the volatility and the boiling point being, the volatility being less and the boiling point being more as we get a longer chain, actually, it's easier to set fire to a vapor or easier to set fire to something which is a gas than it is to set fire to a liquid. So the pattern of flammability actually follows the pattern of the volatility. The more carbon atoms we have, the lower the flammability, and that's basically due to the fact that it's less volatile and its boiling point is higher. There are other factors involved as well. So those are the four properties of alkanes. You need to be aware of what the properties are and what the pattern is with the increasing length of the hydrocarbon chain.